Okay, hello class. Hope you're having a good day today. It's been raining most of the day. I felt lucky to get here this morning. I was ready to get off the interstate, that's for sure. But at any rate, we need the rain, so it's been refreshing today. I have posted for y'all additional assignments on Connect. If you want to go ahead and do those, and I suggest you go ahead and work on those, the week 2 assignments as soon as you can. But right now, to get out to those problems, you'll have to go to the Connect site itself. I attempted a couple days ago to deploy those to Blackboard, to move those over, and somehow I got hung up on that. Not sure, I just kind of realized they never did deploy, so that's a term of art there, I guess. Deploy just simply means to bring them over into Blackboard. And so I've had a little trouble doing that, but you can still do the assignments for now if you'll go out to the Connect site. Okay. If you can get out there on the first assignment or what have you and poke around a little bit, you should be able to find the other 3. I think I posted 3 problems for you to work a couple of days ago. So again, I encourage you to work on that, and you should be fine. I'll try to get those integrated with Blackboard very soon as I can, so it'll be seamless for you, but at any rate, they're out there for you to work on. Okay, so in this course, there's we'll be doing a little bit of math as we proceed through this course, and today I'm going to talk basically in concepts as we get into chapter 3, talk about demand, supply, and market equilibrium. But there's some mathematical underpinnings to what we're going to do today that we really won't address so much today, but it's coming, okay? When we get to chapter 6, in particular, we'll talk about consumer preference theory just a little bit, the axioms of consumer preferences, and how consumers make choices. It's a little bit mathematical, okay? We won't use any calculus, but we will be doing some things with diagrams and so forth. But if you need to dust off your basic math, your basic algebra, what you want to do is you want to go back and review chapter 1, look at the appendix to chapter 1. Okay, there's a math review there. So if you need to do a math review, you go to chapter 1 and take out your appendix, right? Okay, so if you'll do that, I guess I feel like the old Johnny Carson on show. That one deadpanned, I guess. But look at the appendix in chapter 1. And then not every chapter has an appendix, but that one does. And you learn about lines, again, equations of lines, and some of these things, intercepts, and point slope formula, and all that is addressed in the appendix. So go back and review that. So we assume that you know that. So the material we did, I don't know, 2 or 3 lectures ago. So this is the 4th lecture. So it was either the first or second day of class. And when I sketched a budget line on the whiteboard, that's something we'll be revisiting. So go back and review the budget line that we talked about, and how a budget line is sketched in 2 space, and how you find the 2 intercepts on the goods axis, the x and the y axis, and so forth. And because we'll be using that. We will be using that when we get to what we call consumer preference theory, which is really built, or it's the underpinnings of chapter 3 that we're going to look at here today. But so I'll give you a little time to review that before we kind of launch into the mathematical support for that. So at any rate, we're in chapter 3. I'm going to see, I'm trying to wean myself off of the book and the PowerPoint slides for various reasons. So hopefully, I do appreciate everyone bringing your laptop. Just about everybody has a laptop today. And so you can view the book as I refer to diagrams and so forth. So I have to kind of resist the temptation, since we're on the air, I suppose, to using the book very much. So at any rate, that I will attempt to do today. So in chapter 3, we look at demand. So let's go here to the document cam for a moment. This is something everybody associates with economics. We've all heard of demand and so forth. Okay, you are a demander of a good if you are both, if you have both the willingness and what? You have to have the willingness and ability. You have to be willing and able. A-B-I-L-E is, that's not right. This is able. A-B-E-L, isn't it? Or is that Cain and Abel? I don't know. This is embarrassing. Somebody help me out here. A-B-L-E. Of course it is. That's Abilene, isn't it? A-B-L-E. I'm sorry. But when you're in front of a crowd, you know, I'll never criticize the president when he's on national TV or giving a press conference and can't think. So you'll experience that in your speech class. A-B-L-E, of course. All right, so you have to be willing, you have to be able to purchase the good in question, to be a demander. And so we can sketch the set of people who are willing and able to purchase a good in something called the demand curve or demand schedule. And so they have one of these pictured in your book, a demand schedule. I mentioned last time a demand schedule or demand curve. Let's just sketch the curve here. Is a downward sloping line. Maybe it looks like this. Doesn't have to be linear. We will be working with linear demand curves quite a bit. But you always put P on the vertical axis in quantity, the quantity of people who are willing and able, or the units that someone is willing and able to purchase at these various prices. You plot those along this curve here, and you'll trace out a demand curve, okay? So, a couple of things here. First off, I mentioned last time that, I wonder why this isn't showing on the front. Can we fix that? Or is this something that it's not, the class can't see it? We can do what?
We like the links.
Yeah, we like the links. He's a lot better looking than your professor. But at any rate, if there's any way we can get that, I don't know how for the class. I hate for you to have to turn around to see this. I see it on the back screen. But there's a, what we see here is that for various values of P, and I could, you know, back in school you learn how to sketch a graph. You know, generally we would do X and Y, right, to sketch a function. But instead, of course, this would be the X-axis and the Y-axis. But instead, what we're going to do here is we're going to put P and Q. P for price and Q for quantity in place of X and Y. Now what you see is, wait a minute, Dr. J, you goofed here. That's the Y-axis. Why didn't you put P over here and Q here? Okay, so we're good? Okay, wonderful. Thank you, Radar. Or is that Mallory? Okay, thank you. And so everybody should be able to see it up front there. Okay, so we mentioned this last time, that P is like X. Normally in most sciences we would use X as the independent variable, but price is the independent variable when we do most of economics. This is the independent variable. And so you may say, well, why don't we put it on the horizontal axis? After all, okay, when you did this back in school, you would arbitrarily select values of X and find corresponding values for Y, right? We don't need to go through that. That's how you did it back in school. What I'm saying now is to sketch a demand curve, you arbitrarily choose prices. Like, so we'll get rid of these. We'll choose like $5. Okay, and so there's 10 units demanded, or 10 units in a period of time, maybe in a week. This would be gallons of gasoline. So I'm just going to put here gallons per week, okay? So you have to have a period of time here, like a week, a year, what have you, when you talk about demand. I mean, over a century, you're going to have a lot higher quantities than I want to have here, so you got to be specific there. And then we have the units here. Be it gallons, be it tons, whatever it is you're measuring the quantity or commodity in, you got to have that here. So we're talking about gasoline here, okay? This is the demand for gasoline. And so I'm going to select kind of willy-nilly or arbitrarily some various prices here. At $5, there'll be 10 gallons per week. Let's just say from the average consumer out there, the average American, at $5 a gallon, they are willing and able, okay, to purchase 10 gallons in a week. As the price goes down, though, say now it becomes $4, this is say is 20, and so forth. And so, first off, what I'm doing is I'm treating P as the independent variable. I'm just arbitrarily selecting some values for the price. Okay, now a couple things. Why? Why am I treating the price as the independent variable? It's because the quantity that consumers are willing and able to consume is a function of the price. That's the direction. Look at the causal direction here, always. Ask yourself, when you think in terms of supply or demand, ask yourself which variable causes the other variable. In this case, it's prices that determine the quantities people demand that are willing and able to purchase. So as the price goes down, you're willing and able to purchase more. And that's the law of demand. As these prices go down, the quantity that people are willing and able to purchase goes up. So there's this negative relationship between P and Q. Okay, so we see here at $3, say there's 25 or 35 units demanded. At $2 is 55, and at $1, let's say that there's 80. And of course, I'll put the infinity sign here. If they're giving gas away $0 a gallon, well, you know, everybody's going to be out getting some of that, right? But there's first off a negative relationship. That is to say, if one variable goes up, the other goes down. They go in opposite directions. So as I do this, first off, I'm treating price like I would X in a normal situation, other sciences. That's my independent variable. But the problem in economics is, of course, we got the independent variable on which axis? We got it here on the vertical axis. So economics is one of the few disciplines at the undergraduate level. It varies. If you take a chemistry class, you might see this or what have you. But for the most part, we think in terms of the independent variable being on the horizontal axis, not on the vertical axis. But instead here, the causal variable, the independent variable is on the vertical axis, and the dependent variable is on the horizontal axis. So you want to get used to that. It's a relic of the very first, I think, economics textbook that caught much traction out there. Alfred Marshall's textbook in the late 1800s, if I remember right. He did this in this way. So we've been living with it ever since. There's no real reason why he couldn't have done it this way, right? Couldn't have put the price axis here and the quantity axis here. Could have flipped that about the 45-degree line. All the theory would be the same. But here's what we encounter when we talk about microeconomics, though. We'll talk about increasing demand here in a minute. We've all heard people say, oh, there's been a demand increase and what have you. When I say an increase in demand, that's going to refer to a shift of this curve. But we don't shift it up, even though it may look the same, but you shift it to the right. We're going to be shifting the demand and the supply curve left and right because, again, the independent variable is on the horizontal axis or vertical axis. And so we measure quantity demanded. Say here again at a price of $5, if you can read that, the quantity demanded is 10 gallons. And at a price of $4, the quantity demanded is 20 gallons and so forth. So we measure quantity demanded. That is the distance out to the curve horizontally, not vertically, okay? So, I mean, you may resist this. Students get hung up on this a little bit. But if we refer to point A here, point A, and I say, what's the quantity demanded, you may be tempted to say, well, I'm going to measure this distance. No, instead, the quantity demanded is the distance from the axis, the vertical axis, to the curve itself. So, the law of demand says this, basically. And they give you the law of demand on page 46 of your book. I'm resisting the temptation of using the book here and on live TV, but the law of demand, okay? Law of demand. I'll get better at this, but we can do this today. Law of demand is the principle, your book says, that other things equal, an increase in the product's price will reduce the, and there's a word there I want you to underline when you see it in your text, quantity demanded. All right. You may think I'm splitting hairs here, but this makes tremendous amount of difference. There's two terms we're going to look at here. We're going to talk about demand, and we're going to talk about quantity demanded. Two different things. Okay? So the law of demand says that P and quantity demanded, I'll use Q sub D here. What this means is quantity demanded are negatively related. Negatively related. And then I'm going to put, since you got your book and so forth, you can read the English, but I want you to get used to this because I mentioned this before. We write the word set par, C-E-T-P-A-R, ceteris paribus. The price of a good and the quantity demanded of a good are always negatively related. That is to say, if one goes up, the other goes down. Now, this is the one we start with typically. So if that goes up, this goes down, vice versa. If the price of a good goes down, quantity demanded goes up. We see that here in the little T-chart that I made. And again, we see this graphically here if you were to plot those points out. I mean, you got the point at $2 a gallon for gasoline, I guess. I'll come on down here. The quantity demanded is 55. Not the demand, okay? It's important. We're measuring horizontally here to the curve, and that is quantity demanded. So when I say Q sub D, that's this distance right here, okay? Quantity demanded. All right, so this is the law of demand. Again, I said last time kind of jokingly, you got to watch your P's and Q's. It actually comes from economics, economic situation anyway. You got to watch your prices and quantities here. The law of demand. Now, we all know this intuitively. We would respond to a change in price of gasoline this way. It would negatively affect our consumption, really, or you know, be careful. Our willingness and ability to consume gasoline is negatively related to the price of gasoline. Now, there's three reasons for this, okay? There's three reasons. Three reasons for the law of demand. Okay, so your book gets into this a little bit, but the first one is price is an obstacle to consumption. Price is an obstacle to consumption. Okay, so what I mean by that? Well, obviously, I mean, just common sense here, but you kind of have to get over the price when you put your credit card down to buy something, gas, or write a check, or peel off $20 bills. You have to overcome an obstacle there. So one reason here is price is an obstacle. And I could say to purchasing, no big deal, but that's the first reason we have the law of demand, a pretty common sense. The second reason, okay, is because of something called diminishing marginal utility. Okay, diminishing marginal utility. We're going to see this all over the place in economics. Now, we have talked about the word marginal before. Does anybody remember what the word marginal means? Remember, I took my book. I guess I shouldn't have showed it on camera. Took my book. Yeah, it's the white paper around the text, right? So what point was I trying to make? The marginal then is the
fringe edge.
Okay, all right, very good, very good. All right. So it's the edge or the additional unit. I'll just give you an idea. What if you every week you purchase 500 gallons of gasoline? Every week you purchase 500. You drive a big truck up and down the road. You said, this week I'm going to buy one more gallon. So you're going to buy 501 gallons. Well, that last gallon is the marginal. It's on the fringe, as you say. It's on the edge. Okay. Now, this is a ubiquitous relationship. this is common sense. In economics, we have to start somewhere with some common sense principles. When we look at consumer behavior later, more strictly or more precisely, I guess, in Chapter 6, we'll have to keep this in mind, that anytime you consume a good within a finite period of time, the utility or satisfaction, it's just a fancy word for satisfaction, that a consumer would derive from that good will diminish at the margin. Okay? Now maybe it's a little hard to see with gasoline for a minute, but just say for a moment, I mean, I've gotten on this kick here. I don't know if this is a good example or not, but I eat a lot of boiled eggs all the time. But so, you know, typically we eat like a half a dozen of those in a day. That's probably more than I should. I'll get more cholesterol than I want. I'll tell you what, that first boiled egg I eat in the morning, man, that's good. Okay, now I'm talking about a 24-hour period of time. That first one delivers a lot of satisfaction. The second one, what do you think? More so or less so than the first one? That's right, thumbs down, less so. Now I'm going to use, really, when we talk about utility, we'll look later, it's kind of hard to quantify utility, but I'm going to use a unit of utility. It just means a measure of satisfaction, okay? And we'll have, when we get to utility functions later, we'll have to note the fact that utility functions are ordinal, okay? That you can order goods by their utility, but it's kind of hard to quantify how much satisfaction you derive. But we can do this. We can say you got more satisfaction out of the first egg than you did the second one. And of course, the second one out of the third one in a period of time. Now, if I free up a period of time or over the course of the year, it doesn't matter, right? It's a long period of time. But the point is, we all experience or witness diminishing marginal utility. Diminishing utility or satisfaction derived on the marginal unit as you consume more and more of a good. Now, going back here just a second. We see that here, okay? We see that here. Maybe if I put a decimal here instead of 10, I had 1, 2, and 5.5 gallons, what have you. But we could kind of say that that first gallon of gasoline must provide satisfaction that I would equate to $5. I mean, I could do a lot of things with $5, right? Maybe I could buy a roller coaster ticket or something, get a lot of whee, okay, out of $5. The idea here is that I get just as much whee satisfaction out of that first egg. I get $5 worth, okay? Or in this case, the 10th, if these were eggs here. But what you'll notice is with the next unit consumed, the satisfaction on that marginal unit goes down. We see this here. If we try to quantify utility in dollar terms, this is exactly the kind of curve you would get. So diminishing marginal utility is a very good reason for the law of demand. Okay, these three reasons here are three I want you to hang on to because I'll be asking you about them, like on the test and so forth. Maybe write about it a little bit. It'll say, explain to me how diminishing marginal utility affects the shape of the demand curve and why. Okay. The third thing here is there are two things going on here when you consume a good at differing amounts over differing periods of time. There's something called the, I'm going to write it in this order, there's the substitution effect. The substitution effect, and there is the income effect. Okay, I'm going to deal with these separately here. So what do I mean here? Okay, first off, again, with the demand curve. We say that if price goes down, quantity demanded goes up. Quantity demanded is this horizontal distance. If price goes up, quantity demanded decreases. Now why? First off, substitution effect. What do I mean by that? Okay, as a price of a good, I'm going to say P sub X, increases, okay? So as the price of a good increases, its price relative to other goods that you might consume increases under ceteris paribus conditions. Remember, I wrote set par up here. Remember what that means? All other things are the same. These two are inversely related if I don't allow any other prices in the economy to change. So if we're talking gasoline here, price of gasoline is indirectly related to the consumption quantity demanded of gasoline. So long as we don't change the price of bus tickets in a city, okay? If bus tickets have been $100 a day, okay, and the price of gasoline goes down, for sure I'm going to consume more. But if bus tickets are essentially free, if the price of gasoline goes down, I may or may not consume more or that much more. Okay, what if the price of a bus ticket goes down as the price of gasoline goes down, but bus tickets really go down? Okay, well, I'd consume more bus tickets, not gasoline. The price of gasoline goes down. So here's the deal. You might think about the economy this way. There's all these levers we're going to be looking at that determine a market like gasoline. And for the market for gasoline, you have other goods that compete with it. You have other goods that are used with it. You have individuals' income, all of these other things. We're saying that you only allow these two variables here to change and hold everything else constant. So you got all these levers. You can imagine kind of a switchboard here. And you only flip up two switches: prices of gasoline, quantity demanded of gasoline. You free those up and you hold everything else constant. If you do that, then you can trace out this curve in two space. See, a curve traced out in two space allows for only two variables to change, not anything else. Nothing else is changing but these two variables here. If I talk about the price of a competitor good like bus tickets, then I got to take this curve and shift it left and right. We'll talk about that in a little bit. Or if we talk about people's income going up or going down at the same time the price of a gasoline goes down, then I actually have to pick this curve up. You see, if I move from A to B to C, just tracing this out, doing this thing here, these are the only two variables, price and quantity, I allow to vary. I got also income over here and other things, the price of bus tickets. Those are going to be held constant. These levers here, if you will, those switches, they're set on constant. These two can vary. And if I do, I get the law of demand. They're indirectly related. And one reason here is with a substitution effect. As the price of gasoline increases, its price relative to bus tickets would have to go up because you're holding the price of bus tickets constant. Does that make sense? Okay. So that's called the substitution effect. Now, if you got a choice to make between two goods and the price of one good goes up but not the other good, then you make a substitution. This is rational behavior. You substitute away from the good when its price goes up. Right? You'll substitute toward the good if the price goes down. Okay, so this is called the substitution effect. The other is over here. Okay? This is called the income effect. And here's the deal. A higher price, or let's just say the same thing, as the price of gasoline, good X, goes up, the buyer's real income goes down. As the price of gasoline goes up, the real income goes down for buyers. Now you imagine people in a city, there could be an average income of $50,000 a year in the city. Suddenly, for some reason, the price of gasoline spikes, okay, goes up. Well, everybody buys some gasoline. let me ask you, do you think as a result of that spike in the price of gasoline, people are able to, on their budget or on their paycheck, are they able to enjoy more goods and services than they have previously, or fewer? Fewer, obviously, right? Fewer. Okay, so you want to think in these terms. As a price of a good goes up, your real, not your nominal, not your dollar income, you might be making $50,000 before and $50,000 a year after the price increase. That's your nominal income. Your real income is what you can purchase with your nominal income. And so we have a way of doing that. We price a basket of goods. You learn about this in our macro course, kind of a typical basket of consumer goods. And everybody buys some apples and some eggs, and they pay their rent and so forth. Those are things in your basket. But one thing that's in that basket is gasoline. So if the price of gasoline goes up and you're still living on $50,000 a year, then in that year, maybe that's $1,000 a week, okay, since we got gallons per week. So the price goes up. You can't buy as much gasoline as you did before, right? Or your real income goes down because there's not going to be as much in your basket this week of goods because the price of one of the goods that you typically put in that basket's gone up. That's called the income effect. You see the difference here? With the substitution effect, we are looking at changing the price by holding other prices constant here, and we notice that its relative price of the good changes. Over here, as the price of gasoline goes up, then your real income changes. And for most goods, I'm going to call these normal goods. In fact, I'm looking ahead just a little bit. But for what are called normal goods, when your income goes down, you demand fewer. The quantity demand is fewer or less. Okay? For most things, like you would have in that basket, if your income goes down, then you purchase less of it. Gasoline's certainly one of those. There are a few things that if your income goes down, even your real income goes down, you would buy more of. Those are called inferior goods. Your book talks about normal and inferior goods, okay? Sometimes you call them income normal and income inferior goods. I guess this is defined for you later in this chapter. I'm looking for the page number. I don't see it. But it is in chapter 6. Just don't happen to see it at the moment. Okay, there are some goods that are called inferior goods. If the price of X, gasoline, goes up, we would expect to demand fewer gallons of gasoline because it's a normal good. But if the price of ramen noodles goes up, what do you think? Or black and white TVs, do they even make those things anymore? Or efficiency apartments. What if the price of efficiency apartments, because of city policy, there are always controls on small rental units in these big cities. What if, you get a different mayor and city council, the price of a 2-bedroom apartment goes up. People aren't going to want more of those. They're going to want fewer of them. There are certain goods that when your income goes up, you want fewer of. Those are called inferior goods, in which case, you would demand more if your income goes down. Okay, can y'all read my writing there? If your income goes down, you demand fewer normal goods. You demand more inferior goods. Okay, so price of gasoline goes up. Your real income goes down because you can buy fewer stuff now. And when your income goes down, you would demand fewer normal goods, but you would demand more inferior goods. Gasoline is a normal good. If we were looking at the market here for ramen noodles, though, which is kind of the classic inferior good, we were looking at that market, you would say, well, wait a minute. If the price of ramen noodles goes up, your income goes down, and you're going to demand more ramen noodles. Ramen noodles. Are y'all following me? All right, so you may say, well, wait a minute, that violates the law of demand. Okay? Well, it works against the law of demand, but let me tell you that these two things are always happening at the same time. And this is going to be the bigger effect than this. So, if we're talking about ramen noodles for a minute, the market for ramen noodles, yeah, if it goes up, people will substitute away from ramen noodles because the price of ramen noodles is relatively higher than the price for chicken or other things that might compete with it. However, there'll be a tendency to buy more ramen noodles as its price goes up because it's an inferior good. What I'm saying, though, is that even though for an inferior good, the income effect mitigates the substitution effect or offsets it, it doesn't completely so. Okay? So, here's the deal. Let me just write this down here. It kind of as a rule here. For normal goods, I mean income normal goods, the substitution effect and the income effect work together. Work together. They're in the same direction. That is to say, if you have a price of the good, normal good, gasoline again, or steak, or, now I didn't say potatoes. Potatoes might be an inferior good, right? Some people, the poor Irish in the mid-1800s, that's all they had to live on, if they had anything to live on at all, right? So many of them would have said, well, if my income goes up, I'll never eat potatoes again. That would be an inferior good. So we're going to start with normal goods. Most things you buy, so we use the term normal there, that if the price of the good goes up, the quantity demanded, like we see right here, the price goes up, the quantity demanded, this distance here to the curve, decreases. For normal goods, because of the substitution effect, that is to say the good is relatively more pricey, the price has risen relative to other goods, and the income effect, because if the price of this gasoline, say, goes up, your real income goes down. If the price of if your real income goes down, you're going to buy less gasoline. Okay? So these work together. Both of these have a depressing effect. Both of these would cause the price in question to go down. I'm sorry, the quantity in question to go down. I meant to write a Q there. These will go down if the price in question goes up. So if the price of gasoline goes up, that's going to force the quantity of gasoline demanded to go down because of these two reasons right here. That's for normal goods. For inferior goods, and I think you can see before I go on to inferior goods, obviously if the price goes down, then these are both going up. They're always opposite. These are always opposite and these are always opposite. For inferior goods, okay, if the price of gasoline goes up, then because of the substitution effect, the quantity of the good goes down, but because of the income effect, that would tend to make the quantity of the good go up. All right? Well, you may say, potentially the law of demand could be violated here. Well, no, because this effect is always bigger than this effect. Okay? It's bigger. So this mitigates this cancellation here, this offsetting effect mitigates but does not completely cancel this effect. So on net, if you put these together, you're still going to have a downward quantity demand as a result of an increase in the price. It's going to, inferior goods don't show as strong a relationship here, negative relationship between prices and quantity demanded, but it's still negative. Now, okay, Hope that makes sense. Now, let me just mention this for a minute. Theoretically, I mean, you say, well, why? Why is this effect always bigger than this? Could the income effect perhaps be bigger than the substitution effect? Well, we can do that on the chalkboard, on the whiteboard. We can hypothesize such a thing. And really, to come up with something like that, you'd have to think of something that's a real staple for consumers in a very low income economy. Okay? So if it's something they got to have to live on, the price goes up a little bit, they say, well, that frees up enough, I can buy a hamburger now or something like that. But they might buy, in other words, there might be an instance where the income effect swamps the substitution effect in theory, but it never happens in practice. I sit here now and try to think of something that might approximate it, but it never happens. This is always going to go down. This effect, the income effect, will never be bigger than the substitution effect. So that the substitution effect is going to tell you what direction the quantity demanded is going to go. If that were to happen, you'd have what's called a Giffen good. Let me just mention that for a second. For a Giffen good, it's a theoretical idea. It says that the price and quantity demanded are positively related. Positively related. That is to say, the demand curve for a Giffen good would be upward sloping, not downward sloping. That's weird. Okay? So we can theorize such a thing, and it would have to require that the income effect swamps the substitution effect, but in reality, we never see that. Okay, and around the world, you can't think of a good that does that. So it's one of those things, okay? It's just one of those things that we can talk about in the abstract, but that do not happen. Okay, so there are 3 reasons for the law of demand. You want to read the detail in your book on page 47. I'm just kind of trying to give you an idea of what these 3 things are. But again, price is an obstacle. Second thing, diminishing marginal utility. The third thing is because of the substitution effect and income effect. The substitution effect deals with relative prices changing. The income effect deals with the fact that your real income changes when you tweak the price of a good. Okay, 3 reasons. Now we'll spend a little more time, I think it is in chapter 6, when we get to consumer preference theory there, and maybe give a little more rigor to that. So this is called a demand curve for an individual. So this one individual at $5 will demand 10 gallons of gasoline in a week. Now we're going to move to the market. Okay, any questions on this? Okay, suppose this is one consumer here. This is Jan. Jan is one of 3 people who makes up an economy. Okay, you also have, let me call this person Joe. Yeah, thank you very much. Because I'm trying to follow your discussion in the book a little bit here. So you got Joe, you got Jan, and you got Jay. Okay, Joe, Jan, and Jay, and we can look at these various prices here, just as I did this little table here, $5 down to 0. These would be prices for gasoline, 5, 4, 3, 2, 1, and 0. And what we've plotted here is for Joe's demand schedule, is we see that at a high price of $5, he demands 10, and so this is 10, 20, 35, 55, 80, and gosh, if you give it to him, he'll take it all day. But this is just Joe, okay? Now, if we cover that up, we could get the demand schedule for Jan, right? And now I can put some numbers here as well. We could plot this out. We could ask her or observe the 1 week when it was $5, she purchased 12 gallons, and then 23, and then 39 when it got cheaper. Wow, 60, and 87. And again, all right, that's Jan. Now, these numbers have to go up as these numbers go down, the negative relationship. So this is the quantity demanded for Jan. And then, of course, for J, you got 8, 17, 26, say, 39, and 54. Okay, this is a little stylized, I guess, but this is an economy with 3 people in it. Okay, not a very big town. But we're going to go to market demand now. Market demand says all you have to do to get the total market demand, total quantity demanded. And I use a big Q here. Could have used a little q when I talked about individuals here. Doesn't matter. But certainly when I go to market, I'll use a big Q here, and I'll get this quantity demanded by adding across here. Okay, so that should make sense, right? So this is 30 and 20 plus 23 plus 17 is 60 and so forth. So I'll get here 100, 154, and 221. Does that make sense, what I'm doing here? Okay, this is called a market demand schedule here. When I plot these values of Q against these values of P. Now graphically, all I'm doing is this. Again, remember that that we have to use the vertical axis as our independent variable. So just a moment ago, I had Joe here. I was sketching Joe, and I had a curve that looked like this. In Jan, I have a curve that looks like this. And for J, I have a curve that looks like this. And they do this for you in your books, no big deal. But what we're saying, we'll just select one price here, $5. The quantity demanded for Joe at $5 is 10. And then it's 12 and 8 for the other two. So this is 10 at the same price, okay? $5. This is 12. And at $5, I could scoot this over. It's not really to scale, but this is 8. So the point here is when I form the market demand, these are individual demands, individual demand curves. When I form the market demand, I do what's called horizontal addition. Horizontal addition. I take each price. Maybe it's at $5. Okay. At each price, and I add these horizontal distances together. So obviously, I get a curve that's shifted out here a ways, right? Important. And this distance here at $5 is equal to the quantity demanded across the board at $5. So I add 10, 12, and 8, and I get 30. So I come all the way out here to 30. And so I do this for each price, okay, and so forth. $4 and $4. I do horizontal addition. In math, they talk about the superposition principle and so forth, adding functions together. In your algebra course, you may be accustomed to adding vertically, but we don't do that here. Okay, when you form a market demand or a market supply curve, which we'll look at the market supply in a minute, you add horizontally, point by point. You add horizontally, and you'll get a market demand here. Okay, this is a market demand curve, very important curve. Okay, I'm just going to call this D1 here for a minute. D1. That's your market demand curve. Now, if the price goes down to $4, the quantity demand will increase to 60. So, maybe it's, well, I guess it's not the scale, is it? So I got a little thing here. Doesn't matter. So if the price falls, the quantity demanded increases and so forth. Okay, now this again is quantity demanded. What I did not say is this. This is what you want to catch. Okay, this is the law of demand, after all. When the price falls, demand does not increase. Demand does not increase. When price falls, the quantity demanded increases. That's different. I did not use the term demand, I used quantity demanded. Okay, so first off, I'm allowing only these two variables to vary when I trace out this curve, because this, after all, is the price axis and this is the quantity axis. I'm moving my pencil in two space. Everything else is, I'm in flatland. Nothing else is changing but these two variables. And so to do that, go from one point to another, you are changing this distance, the quantity demanded. That's this distance. We are not changing the demand. So it is incorrect to say that the law of demand would specify that when the price goes down, the demand increases. That's not correct. Okay? I don't mean to sound like your English teacher or, the margin wizard over in the library or whoever says, oh, you missed that one, you missed that punctuation. This is vital to what we'll be doing. Because if I said the demand increases, then that is to say that the curve itself shifts to the right. Okay? Not up, as you would in another course, to the right. There's a difference between an increase in quantity demanded, which is a rightward movement along a fixed curve, demand curve, and an increase in demand. Okay? An increase in demand. So that's very important because we're going to be looking at both here. So this moving from A to B to C is an increase in the quantity demanded. Okay? So let's talk about increase in demand then, or decrease in demand. I guess I assume you can make the equivalence here. When you have an increase in the price, there's a decrease in the quantity demanded. You'd be going from point C to point A. Now, what do we mean by something called an increase or decrease in demand? This is the result of actually moving the demand curve itself. I don't know what's happening to our focus. Maybe it'll get in line here in a minute. But an increase in demand is a right shift. A decrease is a left shift in the curve. So, do we have a problem on the camera here? Sometimes I don't know. Class, okay, now I can't see it. Okay, it's up here. All right, class, we are experiencing, I guess it's something to do with, okay. Don't know. Okay, we don't know what's going on. Okay, well, that's not going to work, is it, class? Let's see. Looks like I'm going to use the whiteboard again, right? Okay, I guess I don't know what why it's not responding. I don't know what happened here. It may be.
Can you try zooming out a bit?
Yeah, let me do that. Okay, let me zoom out. Zoom back in. Well, let me zoom out. I think it's still, if I zoom in, it's not going to be there. Okay, we'll go with this. Okay, this will work. I might be able to zoom in just a tad. Okay, thank you. That's a good suggestion. I appreciate that. All right, so here's something here. Just a moment ago I said if the price goes up, the quantity demanded goes down. So those are indirectly related. One goes up, the other goes down. Now, it could be if you're looking at a good, it could be that the price goes up, and as a result, there are more people willing and able to purchase the good. That is, the quantity demanded goes up because there's been a rightward shift in a demand curve. D1 shifts to the right. And we're going to see this in just a moment. But we're going to see with a supply curve. I'm going to go ahead and put a supply curve here. With a supply curve, the market's going to move from one point to another. And I want you to see something here. This is called an increase in demand from D1 to D2. I hope that's still visible. Yeah, there we go. Left shift would be a decrease in demand. Okay, we're going to see, this is called the market equilibrium point here in a minute, and I put an upward sloping curve. It's called the supply curve. We're going to talk about that too, the supply side in a minute. But I want you to see something. I want you to see that the market moves from this point to this point as the demand shifts to the right. This is the quantity axis, and this is the price axis. What this is saying is that there's been an increase in the price observed for a good simultaneous with an increase in quantity demanded. Okay? Because there's been an increase in demand, which is a rightward shift of the demand curve. Prices and quantity demanded can move in the same direction, but only if we allow for the demand curve to shift. Okay? Now, what would cause the demand curve to shift? Okay? Well, it's when you change one of these other levers I was talking about a while ago. When you change something other than these two variables right here. So first off, I want you to note this, okay? That while it's true for a single demand curve, you have this indirect relationship between prices and quantity. But when you allow the curve itself to shift, the demand curve, it can be that the price and the quantity demanded move in the same direction, not in opposite directions. That can happen if the demand curve is free to shift. So the demand curve is free to shift if, or we say it can change. Changes in demand can result from other things. And I alluded to these a while ago. One is if your income changes, okay? So if the price of gasoline goes up, just use your head here a second. If the price of gasoline goes up, it could be that there'll be more people buy gasoline. I'd say, that's weird. Well, it's not if you allow everybody's income to go up at the same time. You see, if you allow income to vary, then you can allow the position of the demand curve to vary. Or if you allow the price of competing goods like bus tickets to vary, that also can contribute to a situation like this. So if you allow for these things to change, okay, these are called determinants of demand. These are things that determine, that's why we call them determinants, they determine the position of the demand curve itself. And if you change any of these things that I'm about to list, then you will change the position of the demand curve. And consequently, you might get, say, a positive relationship between the price of the good and the quantity demanded. This horizontal distance might increase here as the price goes up. So what are these things that determine the position of the demand curve? Or that is to say, these are things that if you allowed these to vary, that would shift the curve either to the right or to the left. So we're going to go through these, and all you got to do is kind of use your common sense. Okay, you can reason this, okay? I'd like to think that a little bit I use the Socratic method, just a little bit. That is to say, I ask you questions to pull out an answer that you already have, okay? And that's what's neat about this. That's what's neat about microeconomics here. A lot of this is very intuitive. Okay, so the first one here is the change in buyer taste. Change in taste. Okay, change in taste. Now gasoline, okay, you kind of have to have gasoline. Doesn't matter whether you like gasoline or not. But if this were the market for, if we were talking about the market for apples, okay, and we just talked about, you know, what might cause the demand curve for apples to shift. Well, I remember something back years ago. I was pretty young, I guess, but there was this news that came out on apples that you buy in the grocery store, what the apples were coated with, alar, okay? And it's a preservative of some sort. And it's like, oh, that may be carcinogenic. So if suddenly there's a change in taste like that, people don't want apples. If that's the case, because of news that comes out in a medical journal or something, that would cause a left shift in the demand curve. If suddenly, though, that there's information that comes out that apples are good for you, you know, there's something really good from eating apples, thank you, appreciate it, Chris, then there'd be a right shift. in the demand for apples. Okay? So your book says that, they give an example. Physical fitness rises in popularity, increases the demand for jogging shoes and bicycles. Okay? What if, you hear this news once in a while, but I heard just the other day, adults are supposed to get 10,000 steps a day. Now, one of the journals said, you only need 7,000. Okay? It'd be the other way, I suppose, but if suddenly the Journal of American Medical Association, JAMNA, or whatever it's called, comes out with something like that and says, you don't need to jog so much after all. Well, what's that going to do to the market for jogging shoes? That's going to shift the demand curve? Would it shift it to the left or to the right? You don't need to jog as much, right? So that would be a decrease in demand. It would shift the demand curve to the left. You see, that's an example of where you might have change in taste affect the position of the demand curve. People suddenly, for one reason or another, become vegetarians. Well, this news comes out that red meat, say, is bad for you. Well, the demand for hamburgers is going to decrease. The demand curve itself actually shifts to the left. That would be a decrease in the demand curve. So I just put this arrow this way. And it could be that the market price for a hamburger goes down simultaneous with a decrease in the quantity demanded for hamburger in the market. Okay? So this is one thing that would change the position of the demand curve. The second thing, what's the second thing here? Change in the number of buyers. Change in number of buyers. Looks like I'm getting the hang of this. I'm sure this is my fault. I did something to the Elmo or something ago, so this is good. So it looks like it's working. I must have done something. But change in number of buyers. So you know what? I'm of that generation, that's getting kind of old. I'm at the tail end of the baby boomers. So there's more people like me who will need, I hate to say it, but alas, will need services of a funeral home going forward. So if you want to find a good investment opportunity, it could be that invest in funeral homes because the baby boomers are all or invest in nursing homes, invest in certain medical equipment that meets the needs of geriatric patients and so forth. So that could happen because there's a change in the number of people who would buy. In that case, there's an increase in the number of old age people. So that's going to increase the demand. Not the quantity demanded, but it increases gives a right shift to the demand curve itself. For funeral home services, for, nursing home and so forth. That makes sense? Okay. Change in income. Let's see if you guys can help me figure this one out. Change in income. This is very good here. Change in income. If your income goes up, what happens to the demand for most goods? Okay, that's right, it goes up. Does it go up for all goods?
Usually.
Okay, well, but we looked at some examples a while ago where that's not the case. Okay, so this all depends on what kind of good. Most goods, we call normal goods, would have a right shift. This would be, an increase. Both would be, it doesn't matter what the good is, this would be an increase in demand. But what I'm saying is, the increase in demand would result from an increase in income for normal goods. So this is the result of income increase for normal goods. Okay? You would have a rightward shift in the demand curve if there's a increase in income for normal goods. If you have an increase in income for a city or something, maybe there's one employer in town. We had a city here with 3 people in it, but there's one employer in town, they give a raise to everybody. Okay? Well, I'll guarantee you, everybody in town is going to be looking for a more palatial place to live and so forth. So certainly efficiency apartments, the demand for efficiency apartments is going to go down in that case. So for inferior goods, you would have a decrease in demand. A decrease in demand for inferior goods. Okay? So if income goes up for inferior goods, the demand shifts to the left. If income goes down for inferior goods, demand shifts to the right. But for normal goods, it would shift to the left. Okay? Now this you already know intuitively. Okay? When I explain to you what an inferior good is, you think, oh yeah, I don't want to buy as many ramen noodles, black and white TVs, compact cars and so forth, those sorts of things, maybe even potatoes. If my income goes up, I don't want to buy as much of that stuff. So that's because they're inferior goods. The whole market demand curve would shift to the left if there's an increase in income for an inferior good. Or, for an inferior good. Okay, so this is the third determinant. These determine the position of the demand curve. I would want you to internalize this. Okay, you already probably, every one of these relationships you already know. I'm just showing you something you didn't know you knew, okay? So this is something that we're bringing to the forefront of your mind. The fourth thing that determines the position of a demand curve is the price of related goods. Or if you change the price of related goods, you'll change the position of the demand curve. Related goods. Now, a while ago, I talked about gasoline and bus tickets for a moment. They're related goods. There's two different ways to get to work. I mean, there's other than that, but if you live a ways, that might be the only thing, okay? All right, so if the price of bus tickets goes up, and we're looking at the market for gasoline, which we sketched the demand curve a while ago, that demand curve is going to reposition as a result of an increase in bus tickets. So my question here is, just think about this a second. Do you think the demand for gasoline will increase or decrease when there's an increase in the price of bus tickets? Would that increase the demand for gasoline or decrease it? What do you think, class? Decrease. Okay, all right. Is that right? Okay, let's think this through. You got two ways to go to work. You find out that bus tickets got more expensive. You've been taking the bus, but now you're going to be a little more inclined to do what? Drive your car. Okay? See, bus tickets are substitutes for gasoline. That's a key word there. Substitute. So if the price of a substitute goes up, the demand for the good in question will increase. All you got to do is think it through. So there'll be an increase or a rightward shift, as we have here in that diagram. There'll be a rightward shift in the demand for gasoline. Okay? There'll be a rightward shift. Okay? Because there's substitutes. There's lots of other substitutes we could talk about, especially when we look at food. To some extent, chicken is a substitute for beef. Okay? You can eat chicken or beef. I know you can eat fish and so forth, but if you're on a protein diet, you want chicken or beef. Thank you. So, what if the price of chicken goes down? What's going to happen to the market for beef on the demand side? Would the demand for beef increase or would it decrease? Decrease, right. Just think it through. There's substitutes. So if the price of chicken goes down and every week you eat some of each, you say, well, I want to start eating more chicken, so I'm going to eat less beef. Everybody's going to make that calculation. Okay? So if the price of a substitute goes up or down, then the demand for the good in question is going to move in the same direction. All you got to do is think that through, okay? There's other ways to get to work. There's other ways. I mean, it's building materials that are substitutes and so forth. There's material for making clothes and so forth. Houses, I've noticed here of late, I've seen houses under construction. They have steel studs in the wall, okay? Steel studs. And they're using steel instead of wood. Well, that's wonderful. I'd love to have a house like that. Now, think about this a second. Here's the implications of putting a tariff on steel here in the United States, or increasing steel coming from Japan. So that's another market entirely. If the price of steel goes up, how's that going to affect the market for lumber in the U.S.? That's right. It's going to increase the demand for lumber because they're building substitutes. Instead of food substitutes or transportation substitutes like we have with gasoline bus tickets, they're building substitutes. Okay. Now you also have, not only with substitutes, you have complements. Okay, complements. Complements. Now these are things you use together. It's not an either or, it's an and. The conjunction here is and. So it's peanut butter and jelly. Okay, thank you. So just think about peanut butter and jelly for a moment. If the price of peanut butter goes up, what happens to the market for jelly? The demand for jelly in particular. That's exactly right. So Glenn's got it there. The demand for jelly goes down. It shifts to the left. Use the two together, right? So the price of peanut butter goes up, and you use it with jelly, you're going to buy or want to buy less jelly. Peanut butter and jelly, it seems a little artificial, but that's okay. But here's some compliments. Gasoline again and luxury automobiles. Use them together, don't you? I mean, you got to get that luxury automobile around some way. Now we got EVs now, but if the price of gasoline goes up, people don't demand gas hogs. Not as many. In fact, they demand fewer. If the price of gasoline goes down, so suddenly we're fracking all over the place in the United States, got all this gasoline coming on. By the way, it gets refined somewhere else and brought back. But anyway, more gasoline on the market increases the demand for gas hogs. Okay? So just think that one through. There's some other examples in your book. And the last one is changes in consumer expectations. Changes in consumer expectations. Let me ask you this. I keep using gasoline because we all can relate to it. There's a war going on in the Middle East or something. We think the price of gasoline is going to go up next week. Okay? We think the price of gasoline is going to go up. How do consumers respond to a projected increase in the price of a good? Are they, okay, yes.
You might go fill up your tank.
Exactly. You're going to go buy now, aren't you? If the word is the price is going to go up tomorrow, you're going to go buy now. That's the idea. If you think the price is going to fall tomorrow, then you'll wait and you'll buy later. This is one of the things that made the Great Depression so bad. Let me just say this for a minute. We haven't experienced deflation in our economy since the Great Depression, not much of it at any rate. But there you had deflation instead of inflation. You had a downward spiral in prices. Now you think about how the typical consumer responds to a situation like that, where you think that that refrigerator you want to buy is going to be cheaper tomorrow than it is today. Okay? Or next year. All these consumer goods in the 1930s, people had this expectation it's going to be cheaper tomorrow. So they don't go out and buy today, right? That further depresses the prices. You see, when you have deflation in the economy, there's an additional pressure, downward pressure on prices, and you can get in a spiral that's hard to pull out of. And we had that going on in the 1930s. Okay, here's an introduction to Chapter 3. Please read this for next time. Okay? All right, see ya. Y'all have a good weekend.